So let's just summarize a couple of things that we talked about earlier with regards to the effect of temperature on equilibrium systems. Please note, and this is very important for you to understand this. The only factor that will change the value of Kc or Kp or any other Ks that we're going to meet in the future. You're going to meet some other Ks which are equilibrium constants for specific systems like Kw and Ka and Kb. We're going to talk about those later on. But the only factor that would affect the K values will be temperature, right? So therefore, based on what we just discussed earlier, if you have an exothermic reaction and there is a shift to the left as a result of adding heat, then basically the result would be that Kc or Kp will decrease, right? For an endothermic reaction, where you have an increase in temperature, then the equilibrium position will shift to the right, and therefore, as a result, Kc or Kp will increase, all right? So this is only true for temperature, right? You won't have Kc or Kp increasing if you change the concentration or if you change your pressure in the case of a total gaseous system, or even if you had a catalyst, because we already know that a catalyst will not affect the equilibrium position, and therefore in that instance, Kc will not change. The only factor that will change the actual value of Kc will be the temperature. So therefore, again, you have to look at whether or not the reaction is exothermic or endothermic in order to make such predictions as to whether or not the Kc or Kp value would increase. Okay, so we're going to look at a couple of examples here. The first of which is shown on your screen. You have these three gases in equilibrium, right? Equation is balanced. And then the question says that mixture is transferred from a 1 liter flask to a 2 liter flask. So therefore, basically, what is happening is that the volume is increasing, right? And if you remember, we said that if the volume of a gaseous mixture is increasing, that means the pressure will be reduced to the same extent, right? So since since the volume is doubled here from 1 to 2, that means that the total pressure will be halved, right? So the question is asking, in which direction does a net reaction proceed in order to restore equilibrium, all right? So when you increase the volume, you're reducing the pressure. You're disturbing the equilibrium. The system will try to achieve equilibrium by increasing the pressure, because by increasing the volume, you're decreasing the pressure. So let me just write here. In fact, let me go to my full screen mode here. Let me get my pen here. And then what first thing I'm going to write down is that since the volume is decreasing, that means that the pressure of the gaseous mixture will increase, right? So that means that how will the system respond? The system will respond by decreasing the total pressure. So we have to look at this system here to see which direction shift will correspond to a decrease in total pressure. And if you recall, we have to look at the number of moles of gases on each side. So we have 2 moles here total on the left, and we have a total of 2 plus 1 here, 3 moles on the right. So therefore the answer is that the system will shift in this direction, which corresponds to fewer gas molecules being formed. So therefore, system will shift to the left as a result. All right? And therefore, that's basically the answer, right? The system will shift to the left in order to restore equilibrium. All right? So that's a relatively simple problem. But it's typical of the problem of that type that you could get in a future quiz or test or whatever. Okay, here's another question. Different system, and the question says, is the amount of nitrogen monoxide formed from given amounts of N2 and O2 greater or high at low temperatures? All right. The key thing we have to look at is whether or not the reaction is exothermic or endothermic. And based on information here, plus 180 kilojoules, that tells you that the reaction is endothermic. All right. So what does that mean? That means that we could rewrite the equation as N2 gas plus O2 gas to give 2NO gas. All right? Um, but remember, it's endothermic, so we add heat to the left side. So the question is asking, basically, would high temperature or low temperature favor the formation of NO? So therefore, you have to choose which one that will push the equilibrium to the right to favor the formation of NO. And the answer obviously is that increase in heat will shift equilibrium to the right to favor the formation of NO. And that's basically the answer for this question. All right. So, those are the type of questions you could get. It's all based on Lechatelier's principle. I would say that the basic thing that you need to remember is that whatever stress that you impose on a system, according to Lechatelier's principle, the system will try to oppose that stress in order to restore equilibrium. All right. Okay. So I'm going to stop here, and then we're going to discuss some other things when it comes to equilibrium in a more quantitative way. So a lot of calculations will be involved when it comes to determining the values of equilibrium constants and also determining the concentrations at equilibrium. A whole lot of different things we're going to look at in the next couple of slides. All right, until next time.